Well, here we go. I think I will give you a little description about a new project for this week, and it's all about refraction and you submitting either a video or a picture describing an example of refraction that you might see in your home or outside. Um, okay, can't do anything without a joke. So yeah, this teaching thing isn't working out. Maybe I'll get a job cleaning mirrors. It's something I could really see myself doing. Pause for the groans from the back of the room. You know who you are, Ryan. Refraction, I don't know if you've seen with the videos. I think it's pretty cool. I'm leaving this link if you're still confused about what refraction is after doing the simulations. I'll put this link from Britannica.com on Canvas that you can take a look at. It explains it. But I did want to go through briefly a couple of the questions I got in emails from last week. One had to do with the fish question, and a lot of people said, well, the fish needs refraction so it can see its food, and great puns from people with the seafood jokes. Thank you, Lexi. Um, and a lot of people talked about people not being able to kill the fish. And so I wanted to show you what that looks like, which may help you explain some of the things that you may see at home if you go online and look up refraction videos and you want to get some examples and explain why things look the way they look. Like if you put a pencil in a glass of water, why does it look broken or look a little funny? So um, we have this fishy down here, and the light, whatever light from the sun, is bouncing off the fish. So maybe we can actually draw a sun up here. Um, Here's a sun, right? So the sun has to bounce off the fish here, and that light bounces off the fish. And I didn't draw the refraction here, I know. So Jacob, don't correct me for being wrong. And Finn, I know I made a mistake there. But what I'm really looking at here is the light bouncing off of the fish. And when that light gets to the air, it refracts. And because the speed of light is faster in air than in water, this light ray bends away and then goes to the hunter's eye, right? I think we got to put his eye here, right? Because right there we go. And but we don't realize that that light had taken a bend. So we see, our mind perceives that the light is coming from a straight line. And so we think this line of sight that we have right here, we think that this line continues. And our mind sees a fish in this position. And so the fish is in the wrong position in our minds from where it is in the real world. Um, and so that is why we would miss the fish with the spear, because we may aim too high. It's also why things look a little broken and funny when we look at them through water. So this type of diagram may be helpful for you for this project. One other question that I got last week had to do with, why does the light sometimes bounce back through the object or sometimes go through? So in this prism example here, um, when we're looking at this surface here, right, and we have this refraction going from inside the prism to the air, you can see that this angle is really big, right? It's almost equal to the surface. So we are getting refraction here. But if I change it so that this angle gets a little bigger, right? This one here gets a little bit bigger, then all the light will stay inside this prism. None of it bounces back because this angle of this beam is too big for the light to escape this prism. We call that total internal reflection, and it's what keeps that light inside this prism, and it's what kept the light inside a lot of the examples that you sent me of light making rainbows and staying inside like a water bubble or other objects that you showed me last week. This light staying inside this prism here and not getting out to the surface is the primary technology or primary physics behind fiber optic technology. So you may have heard of fiber optics, and it's how we send data um, through cables now. We are getting more and more a way of sending information as electricity or electric signals, um, and we're using more fiber optics, so we're sending data or information like our internet information um, using pulses of light that go through glass fibers. There's a couple of advantages there, and the main one that we don't lose information due to heat that you may get with an electrical circuit, and we're going to study that in the next unit. So you maintain a lot more of the fidelity of the signal that we're sending, but it's very important that the light that we send doesn't escape the fiber that we're sending either in our telephone poles or undersea cables or underland cables or anything like that. So when we send the light into this cable, um, like this light here, right, we would expect it, well, some of it's going to refract through and leave this glass fiber into the air. But they make these cables in such a way that all of that light stays inside the cable and gets reflected into the cable. So the index of refraction of this cable is very high. And so it keeps that light inside the cable and doesn't let it escape. And it bounces around and bounces around and bounces around until it gets to the other side of the cable. And then you can send a signal from one side of the cable and get it on the other side of the cable without losing any light. And it's pretty fascinating stuff. It's also why diamonds sparkle so much when you shine light on them, because they cut the diamonds in such a way that there's a lot of very angled surfaces, and it keeps that light bouncing around inside that diamond, which gives it its sparkle. So those are some examples of refraction in everyday life, and I'm hoping you can use that maybe to think about how you can explain something that's going on in your own home or something you see outside. Maybe if it rains, we'll get a rainbow. But what I'm looking for from the project is for you, well, really to demonstrate your understanding of refraction by taking a video or a picture of an example of refraction that you create in your home, or one that's already there. Explain it in a Word document by narrating a video or just put some text along with your picture. The previous lab that I asked you to do on the eye and how refraction works for lenses may be, excuse me, helpful as well. That could be another example of refraction. So hopefully that might pique your interest. We're trying to explain why the light is changing its direction. So explain why something might look broken or weird based on refraction. And again, very important, draw a diagram tracing the path of light from the object to your eyes so I can see that you understand what's going on with the light rays. And there are a lot of examples online where you might get some help from this. So give it a shot, and if you have questions, please let me know. We can get on a chat, and if it's really confusing, just shout out. And I hope this is fun and interesting, and good luck with it.